So I was discussing, or rather we were discussing about Bohr's atomic structure. So let us worry about the Bohr's atomic structure and then let's work. So I was telling you that there are two postulates. Okay, there are two postulates. Postulates are unproved statements. Postulates statements which have been given telling that you assume what I am saying is true. So his first postulate was, whether which is first postulate, which is second postulate, doesn't matter. So you can say this is first, this is second, you can say the other one is second, this is first. So the first postulate is that an electron rotates around the nucleus in fixed circular orbits. So this word fixed here means that it is fixed in radius and it is fixed in energy. Okay, so that is what that word fixed there means, that it is fixed in radius and it is fixed in energy. This directly takes care of the objection which was there to Rutherford's model, Rutherford's model, which said that the electron must be releasing energy. So Bohr said, look, I don't know why, but it doesn't release energy. So its energy is fixed. And further he went on saying that as long as an electron remains in an orbit, it neither gains nor does it lose energy. As long as an electron remains in an orbit, it neither gains nor does it lose energy. So this is basically his first postulate. Then 1 minute, I'll be back. Okay. Then his second postulate, the angular momentum. Friends, this chapter is the second chapter in chemistry. This chapter is also the last chapter in physics in your 12th standard. So there is a lot here that you don't know. We just keep assuming that we know and then move on. Then when you do this last chapter in physics, then you get a chance to revise this whole thing. Okay, you get a chance to revise this whole thing. So please don't worry about it. So now we can't discuss what is angular momentum, we don't know. So as of now, angular momentum is just MVR. Mass into velocity into radius is angular momentum. So the angular momentum of an electron is quantized. Quantized is a word which means that it can take only fixed values. Quantized means it can take fixed values. So suppose my mass is 50 kilograms. Suppose I am running in the radius of 10 meters and my velocity is 1 meter per second. So my angular momentum is 50 into 10 into 1, that is 500 SI units. Suppose I am running at 1.1 meter per second, then it will become 550 SI units. Suppose it is 1.01, it will become 505 SI units. So now you see it can take all possible values, but this is not possible for an electron. For an electron, it can take only certain fixed values. What are those fixed values? The fixed value is NH by 2 pi, where N is the shell number or orbit number. So if it's in the first shell, its angular momentum is h by 2 pi. If it's in the second shell, its angular momentum is 2h by 2 pi. If it's in the third shell, its angular momentum is 3h by 2 pi, and so on, where h is a constant called Planck's constant. Yeah, h is a constant called Planck's constant. So his second postulate is that the angular momentum of an electron is quantized. Quantized means that it can take only fixed values. What are those fixed values? It can be only nh by 2 pi, where n is the shell number. So if an electron is in the first shell, it will be h by 2 pi. If an electron is in the second shell, it will be 2h by 2 pi, third shell 3h by 2 pi, fourth shell 4h by 2 pi, and so on. Yeah. So do you understand? Are you able to follow what I'm trying to say? Yeah. Centripetal force is not a postulate. Redox, I told you this week's portion is redox. Yeah. This is the first slide. This is the second slide. Then I move to the third one. Okay. So now there is a previous statement that we made. The one on centripetal force is not a postulate. That's the truth. Any object which moves in a circle requires centripetal force. Now the electron revolves around the nucleus in circular orbits. The electrostatic force provides the required centripetal force. Okay, so this is again a point that we just memorized because your seventh chapter in physics, we will learn about this. Yeah. So what is electrostatic force? K Z E squared by R square. Where what is K? K is a constant. What is Z? Z is the atomic number. Atomic number. That is, it is the number of electrons. Please make notes. Z is the atomic number. Number of electrons present in the nucleus. Sorry, number of electrons present in the atom, which is equal to number of protons present in the nucleus. Okay, Z is the atomic number. That is the number of electrons present, which is equal to the number of protons. E is the electronic charge. So K is a constant, which is equal to 9 into 10 power 9 SI units. Z, I have told you, is the atomic number. Atomic number. Then again, E is the charge on an electron. R is its radius. So this is the electrostatic force. Now, this electrostatic force is equal to centripetal force. This is the centripetal force. You will learn all these things in the respective chapters later. Okay, so that is why this is the last chapter in physics. But we need this for our rest of the study of chemistry. So it is the first chapter in chemistry. Yeah, so I can cancel this R. Then I can say, there is one equation. Yeah, now there are two important equations that we have. One, mvr is equal to nh by 2 pi. This is his postulate. Then you have mv squared by r is equal to kze square by r square. Here v is the velocity of electron. Then r is the radius of electron. These are the two unknowns. Everything else is a constant. Okay, so now you have two equations and two unknowns. So you can solve them. Yeah. From the first equation, I can get v is equal to nh by 2 pi mr, and I can get v square is equal to n square h square by 4 pi square m square r square. I have only rearranged it. I have rearranged the first equation and I have got this. And once I got v, I squared it and then I got this. Yeah, I squared it and then I got this. Now, once I got this, I am getting a v square in the second equation also. I can cancel a r here and bring down. So I can get that v square is equal to kze squared by mr. So this must be equal to n square h square by 4 pi square m square r square. So 1 mr I can cancel here. Yeah. So from here I can find out the value for r. So r is equal to n square h square by 4 pi square k z e squared m. So can you please find this out? Sir, is centrifugal force is involved in the atom? I explained to you, Anirudh, yesterday that there is no centrifugal force. It is a wrong statement which many people make. It's a centripetal force. I explained to you that I told you yesterday that it is a wrong statement. It is a centripetal force and not centrifugal force. Okay. Yeah, there is nothing called as a centrifugal force. Okay. Take it from me. Centrifugal force is outside your syllabus. So you never have to come across anything which talks about centrifugal force. Hey, I don't know whether you guys are not able to see or what. I'm not able to understand. What is it here? E is the charge on an electron. E is the charge on an electron. What is the charge on an electron? 1.6 into 10 power minus 19 coulomb. E is the charge on an electron. Okay, there are only two postulates. First postulate that it is moving in a fixed circle. Fixed means what? Fixed energy and fixed radius. Second postulate, the fact that angular momentum is quantized. Okay, then this is the fourth statement. Fourth slide. In the fourth slide, we are using those two concepts, the concept of centripetal force and the concept that MVR is equal to NH by 2 pi. So when I rearrange this, I got R is equal to N square H square by 4 pi squared KZ E squared M. Now this is the radius of an electron. Yeah, I showed you. There is nothing that I can explain the last formula. I am just deriving it. There are two unknowns. V and R are two unknowns. So I know that if there are two unknowns, two equations, I'll be able to solve them. So from the first equation, I got V. Then I squared it, I got V square. From the second equation, I got V square. So this V squared must be equal to that V squared. So I equated them. Then I got the formula for R. So R is equal to N square H square by 4 pi squared K Z E squared M. There is what else what do you want me to explain? This is coming from the first equation. Okay, so from the second equation, I got v square. Then I equated the two v squares because v squared must be the same. So I got the value for r. This r is the radius of the orbit in which the electron is moving. Yes, these postulates must be there depending on the value of n. If you put n is equal to 1, you will get first shell. If you put n is equal to 2, you will get second shell. If you put n is equal to 3, you get third shell. If electrons could not move, then what is it? Its velocity would be. If it cannot move, now velocity is 0, but it cannot be in an atom. It cannot be inside the atom. Okay, if it is there inside the atom, it should have some velocity. No, voice is not breaking. Voice is clear. Lakshan, I don't know which chapter this is. I don't know. What is m? M is the mass of the electron. Okay, so this is the third slide. This is the third slide. This is the fourth slide. Okay, so I will explain again. So one of Bohr's postulate is the fact that angular momentum is quantized. Okay, now the question is, what do you mean by angular momentum is quantized? When we say angular momentum is quantized, we say that we mean that the angular momentum cannot take any value. It can take only certain specific integral values. So, or multiples of certain values, integral multiples of certain values. So, it is mvr is equal to n into h by 2 pi. So, this h is the shell number or orbit number. Okay, in the first shell or the first orbit, which is called the K shell, it is mvr is equal to h by 2 pi. In the second shell or second orbit, it is called the L shell. L shell mvr is equal to 2h by 2 pi. Then you have the third shell or third orbit, KLM. This is called the M shell. MVR is equal to 3h by 2 pi. So you see it is integral multiples of h by 2 pi. So this is his postulate. He was not able to explain why it is like this, but he says just assume because I am telling. Okay. Then the second factor, second is not a postulate, it's a fact that if something moves in a circle, it needs centripetal force. So who is going to provide the centripetal force? So the electrostatic force Kze squared by r squared is equal to mv squared by r. Okay. Now many books talk about centrifugal force. There is nothing called centrifugal force. Centrifugal force is not in our syllabus. Okay, so we don't need centrifugal force. So now Kze squared by r squared is equal to mv squared by r, where m stands for mass of the electron, E stands for charge, K is a constant, electrostatic constant, 9 into 10 power 9 SI units. Z is the atomic number. Yeah, V is the velocity. So from here I can cut off one r, bring the m down, and I can get v squared is equal to kze squared by mr. So I have one formula here. Okay. Now from the fact that mvr is equal to nh by 2 pi, I can get v is equal to nh by 2 pi mr, or v square is equal to n square h square by 4 pi squared m squared r squared. So here I got a v square. Here also I got v square. These two v squares must be equal because they refer to the same electron. So I'll get n square h square by 4 pi squared m square r squared is equal to kze squared by mr. So this r here gets cancelled. One m here gets cancelled. I want to know the value for r. So on cross multiplication, I will get r is equal to n square h square by 4 pi square k z e square m. Here h is a constant called Planck's constant. N is the shell number. Okay, n is the shell number. Yeah. So this is how we get it. Yeah, h is a Planck's constant. It is another constant called Planck's constant. Yes, theory part is also there in the test. Okay, so here it is. This is the 5th slide. And this is the 6th slide. R is equal to n square h squared by 4 pi squared k z e squared m. You don't have to remember that formula. Don't worry about it. You should just know it, so that in the 12th standard, when I ask or when somebody asks, we should know. Okay. Okay, so if it is done, then let's rewrite that. The only way to learn is to repeatedly write it. R is equal to n square h square by 4 pi squared k z e square m. I explained to you what each of these is, right? Now in these, what can be variables n and k? So I can say this is equal to n and z, n squared by z into h squared by 4 pi squared k e square m. So this is all a constant. This is n squared by z. So I can now say that r is equal to n squared by z into h squared by 4 pi squared k e squared m. This is all a constant. So it is equal to some constant. Let's put c for constant. Constant into n squared by z. So this is the value for r, where n is the shell number, first orbit, second orbit, third orbit, and z is the atomic number. For hydrogen, helium, lithium, beryllium, like that. Okay, so please make a note and then we will continue. Yeah, so okay, so if you are able to get it, then we will move on. So that constant value is 0.529 angstrom units. So 0.529 angstrom units into n square by z. This is equal to R. This you have to remember. 0.529 angstrom units. 1 angstrom is 10 power minus 10 meters. Yes, C is some constant value, 0.529 angstrom units. Obviously, mass is a constant. Radius will have what unit? Yes, Kavipriya, radius will have what unit? Yeah. Anything is tough unless you want to learn. If you want to get into NEET, out of 1.5 lakh students, they are taking only 3,000 students. So I'm sure you understand that it is not easy. Yeah, as far as NCERT board exam is concerned, don't worry. I will get all of you 80% plus in that exam. If you do even whatever work I tell you, if you do that, you will get 80% plus. Planck's constant, the value is 6.6 into 10 power minus 34 SI units. But all those values will be given to you. So this is the first slide. This is the second slide. This is the third slide. This is the fourth slide. This is the fifth slide. Studies in 11th is very different from your study in 10th. Please understand that. You have to put in lot more effort here. Please understand that. And most importantly, if you are determined to get into a good medical college, you will have to definitely put in lot of effort. They will take 3,000 students out of 1 lakh. So they will take 3 students out of 100. So it has to be difficult. It cannot be easy. Yeah, Planck's constant, I told you. So the value of all constants will be given in the question. Yes. No, the deleted portions in NCERT are not deleted in NEET. Here is the first slide. Here's the second one. Okay. So R is equal to 0.529 into n squared by z. So question, so many angstrom units. So question number 1, what is the radius of the first shell of hydrogen? So first shell of hydrogen, n is equal to 1, z is also equal to 1. So R will be 0.0529 angstrom units. Then what is the radius of the second shell? Of hydrogen. So n is equal to 2, z is equal to 1. So it will be 4 into 0.529. So 9 into 4 is 36, carry over 3, 8, 11 carry over 1. So 2.116 angstrom units. Okay, so there can be questions like this. You have to remember this, and then you have to use this particular concept and keep working. So here is the next question for you. What is the radius of the second shell of helium? What is the radius of the second shell of helium? So second shell of helium, 0.529. Second shell n squared will become 4. Z will become 2. So it is 2 into 0.529. So that is 850. So it will become 1.058 angstrom units. Okay. So I hope we are able to make notes. So please make notes and follow this. Yeah. So if you get this, we are happy. An atom need not have only one shell. An atom can have many shells. Hydrogen has many shells. I mean, what do you mean you don't understand? I'm asking you, what is the radius of the second shell of hydrogen? Second shell of hydrogen means n is equal to 2. So n is equal to 2. That's it. So z is equal to 1. So I have given you, this is the formula that we have derived for the radius of any species. And now we are asking, what is the radius? So first shell of hydrogen is this. Now if there is a second, I am not saying there is an electron in the second shell. I am not saying, I am asking you what is the radius. So if I am asking you what is the radius means what? N is equal to 2, Z is equal to 1. I am asking you what is the radius of the second shell. I can ask you what is the radius of the 100th shell of hydrogen. I am not telling that there is an electron there. I am just asking you what is the radius. So that you must be able to do by given the formula for it. Okay, yeah, hydrogen doesn't have more than one radius as far as an electron is concerned. True, an electron is in the first shell, but every element can have any number of shells. There may not be electrons in them. Because we are talking about the second shell of the next element, helium. Helium has n is equal to 2 and 4 is the n of z is equal to 2. So 2 square is 4 by 2. The unit of radius is meters. But when meters are very small, so 10 power minus 10 meters is called 1 Armstrong. Just as you have millimeter, the same way. Yeah, this formula can be used to find out the radius of all elements. So I can ask you, what is the radius of the third shell of lithium? So it is 0.529 angstrom into n squared by z. Lithium is the third element. Third element means z will be 3. So it is 0.529 into 3 square by 3. Cancel. So 7 carry over 2, 8, 5, 1. So it will be so much. You have 1 meter, then you have 10 power minus 2 meter is equal to 1 centimeter. You have 10 power minus 3 meter is equal to 1 millimeter. Then you have 10 power minus 6 meter is equal to 1 micrometer. Then you have 10 power minus 9 meter is equal to 1 nanometer. Then you have 10 power minus 12 meter is equal to 1 picometer. Yeah, in between you have 10 power minus 10 meter is equal to 1 angstrom. Then you have 10 power minus 15 meter, that is equal to 1 Fermi. So these are all smaller units of meter. So this gives you an understanding of how big a hydrogen atom is. Hydrogen atom is 0.529 into 10 power minus 10 meters. So it is that small. So this gives you an idea of how small the hydrogen nucleus is. Yeah. Okay, now the voice must be clear. So this formula is used to calculate the radius of atoms. Yes. Yes, Abhinay, are we able to get it? Yalini, are we able to understand how you got 4 by 2? Yes. When n is equal to 2, formula is telling you z is not equal to 1, z is equal to 2. Oh, for this one you are asking, when n squared by z, n squared is 4, 4 by 1 is 4, so 4 into that much. Okay, so here is the 8th slide. Okay, so if you understand about this, then we will move on. So this is the first kind of question that you can get from this chapter. We will read all these things again when we do physics in the 12th standard. We will be doing these things again. The only way you can learn the 11th portions, 12th portions is by repeated learning. Okay, learning it once is not going to help you in any possible way. Okay, so coming back, so the first thing Bohr said is about the around the nucleus in fixed circular orbits. So what did he mean when he say fixed circular orbits? So he said the energy is fixed or the radius is fixed. Energy is fixed. So radius we understood, n squared by z into 0.529. So we said for the first shell it will be 0.529 by z. For the second one it will be 4 by z into 0.529. Okay, 529. Third one will become 9 by z into 0.529 and so on. So these are all fixed, I understand. Next we want to understand what is the energy of an electron. Yeah, Next, we want to understand what is the energy of an electron. Okay, please understand that none of these derivations you will need. Yeah, none of these derivations you will need. You only need to know the magnitude. So from the previous whatever I have explained, all that you need to know is 0.529 into n squared by z. Okay, I am a teacher, so somebody can ask me, sir, how did you get that? So I explained to you that look, there is a logic for everything. So if you understand the logic, great, but all of you don't have to understand the logic. Even if you know what the final statement is, the final statement is R is equal to n squared by z into 0.529 angstrom units. If you understand what is the meaning of n, what is the meaning of z, very good. So this much is done. Yeah. Now the next one, the question is, what is the energy of an electron? So the energy of an electron is minus 13.6 eV divided by n squared. This time it is into z by n squared. Oh, it is not z by n squared, it is z squared by n squared. This time the energy is equal to this much. What is this electron volt? Just as there are smaller and smaller units of joules, units of energy, units of distance, the same way there are smaller and smaller units of joules. So this is a very small unit of joules. This is equal to minus 13.6 into 1.6 into 10 power minus 19 z squared by n square joules. Yeah, so many joules it is. So this number is a easy number to remember. E into V, 1 coulomb, 1 charge into 1 volt will give you 1 joule. So if you just divide whatever energy you get, if you divide it by charge of an electron, you get the energy in electron volts. This is important for you to understand. Okay, so I will try to derive this. This is only, don't worry about it. So first thing is, the total energy of an electron is equal to kinetic energy plus potential energy. Energy is of two kinds. One is kinetic energy, one is potential energy. Yeah. So the total energy will be this. Then we will make a note. Whenever there are attractive forces, whenever there are attractive forces, potential energy is negative. Whenever there are attractive forces, potential energy is negative. Whenever there are repulsive forces, potential energy is positive. Okay, so what do you think? An electron, does it have repulsive force or attractive force? Attractive force. So it will have potential energy as negative. Okay. Kinetic energy is half mv square. This I hope all of you know. Potential energy, I am telling you, is kZe squared by r, because it is minus attractive force minus. So this is the potential energy. Kinetic energy, I am telling you, or you already know, is half mv squared. Potential energy, you don't know. Potential energy is not mgh. Potential energy can be anything else. So that anything else is minus kZe squared by r, and that I'm just telling you, memorize it. Okay. Already I explained to you that mv squared by r is equal to kZe squared by r square. So 1r gets cancelled. So half mv squared is equal to kZe squared by 2r. So total energy is equal to kZe square by 2r minus kZe squared by r. Okay, now this will give you minus kZe square by 2 times r. This is the potential energy of an total energy of an electron. I will explain to you everything. You first make notes. You first make notes. Don't just bombard saying I don't understand, I don't understand. Nobody can understand this. Yeah, that is why this is the last chapter in physics. But we will just take the important essence of it. This will never come in your exam. But you have to know the total energy is equal to kinetic energy plus potential energy. You also have to know whenever there are attractive forces, potential energy is negative. Whenever there are repulsive forces, potential energy is positive. We will derive all these things later on. Here is the second slide. Here is the 9th slide. Here is the 10th slide. Here is the 11th slide. Here is the 12th slide. I am saying that the total energy of an electron is equal to its kinetic energy plus potential energy. Total energy of any body will be equal to the sum of kinetic energy and potential energy. Okay, then I am now telling you that kinetic energy is always half mv square. There is no change in that. Potential energy is equal to minus kZe squared by r. I am telling you, please make a note of it. In this case, potential energy is equal to minus kZe squared by r. So the total energy, now potential energy is negative. So I am explaining to you why is it negative. So whenever there are attractive forces, potential energy is negative. Whenever there are repulsive forces, potential energy is positive. Beyond this, we don't need. So this is equal to minus half mv squared minus this. Then I am telling you that already we have learned that mv squared by r is equal to kZe squared by r squared. R cancelled, I get the value for mv square. But I need half mv square. So half mv square is kZe squared by 2r. So the total energy is kZe squared by 2r minus kZe squared by r. We don't need all these things, don't worry. So from there I can say total energy is equal to this much. So here what we need to understand is this, that kinetic energy is equal to half the magnitude of potential energy. This is an important question which has come last year also. It was there in the NEET exam. Kinetic energy is equal to half the potential energy, or potential energy is equal to double the magnitude of kinetic energy. Potential energy is negative, kinetic energy is positive. Kinetic energy is half mv square. So V, whatever it is, V will always be, V square will always be positive. So kinetic energy will always be positive. Potential energy depends upon the nature of the force. For attractive forces it is negative, for repulsive forces it will be positive. Okay. We will get the recordings. I don't know how to allow somebody to record, but if you can record, I have no problem. Okay, next class I will explain to you this again. Okay. Yeah, so here is slide 8. Here is slide 9. Here is slide 10. Here is slide 11. Here is 10. Then here is 12. Okay. Yeah, there are a lot of values and concepts in this chapter. Yeah, now break. Yeah, 8 is here, 7 is here, slide 7. Okay, fine. Bye. You will get the recordings. The recordings are all being put up, so that will be enough for you. Okay, bye. சொல்லுங்க மேம்.